This is going to be my third kefir video out of many other ones. So continuing where I left off. Okay, so to start, kefir is a probiotic rich like yogurt kind of drink, and it's a dairy, and it has many benefits because of the many different strains of bacteria, and you can find it for pretty cheap, under $10 depending on where you shop. So some kefir brands, depending on the strain, has vitamin K2. Kefir, it does provide lower concentrations of vitamin K2, but natto which is a fermented soy product, has much higher levels of vitamin K2. Okay, so I'm going to talk about two different vitamin K2s, and one of them is MK7 and the other one is MK4. So MK7 is better because it has a longer half-life in human circulation, and it's often considered more effective at raising serum K2 levels per microgram ingested. And comparing MK7 to MK4, MK4 has a shorter circulation half-life and may require larger or more frequent doses to maintain steady levels. So MK7 would be a better choice over MK4. Okay, so a great way to get more vitamin K2 out of kefir is by microbial strain selection. And some kefir grains have a greater proportions of menaquinone producing bacteria, and some of those bacteria is lactobacillus, possibly strains capable of K2 synthesis. Okay, vitamin K2 is also fat soluble, so choosing kefirs or kefir brands with a higher fat milk, or like a kefir made with a high fat milk, will yield higher extractable vitamin K2, since K2 is fat soluble. Another great way to upregulate or raise the levels of vitamin K2 in kefir is by using milk from grass-fed cows. So by using this kind of milk, it may provide more substrate, which is the vitamin K1 precursor and fat content, therefore aiding the upregulation or increasing vitamin K2 levels in that kefir. Okay, now for lactobacillus species, to effectively increase vitamin K2 production in the gut, several conditions must first be met. So basically having the right gut environment. Okay, so vitamin K2 is synthesized via pathways that function efficiently under low oxygen conditions. So possibly excessive iron could end up providing too much oxygen. Therefore, the vitamin K2 can't be synthesized in the gut. Also, what else is needed for vitamin K2? With lactobacillus, uh, what aids lactobacillus in increasing vitamin K2 is also acidic pH, anywhere around or between 5.5 and 6.5, because lactobacilli thrive in slightly acidic environments, such as maintained by lactic acid production. Okay, so since vitamin K2 needs substrates to be able to form, because the substrates aids the K2 or aids the lactobacillus, that it's critical for the acidic pH to be at 5.5 or 6.5, because this pH inhibits pathogenic bacteria that could compete for those substrates, therefore leaving no substrate for lactobacillus or vitamin K2. Okay, also glycolysis feeds into the vitamin K2 synthesis pathway, and what can help this is the presence of fermentable carbohydrates, because lactobacilli they use sugars such as fructose. So fruit sounds like a good choice for the gut, because fruit has fructose. And lactobacilli also uses glucose and lactose. So dairy products contain lactose. And all these different types of sugars are needed to produce ATP via glycolysis and pyruvate fermentation. Okay, now in this part of the video, I'm now going to explain some of the nuts and seeds that could possibly help lactobacillus create a vitamin K2. So the first nut here is pistachios, rich in polyphenols, high in prebiotic fiber. So that's supposed to feed the gut bacteria in the gut. But most importantly, pistachios increases lactobacillus and bifidobacterium populations. So that means that pistachio helps vitamin K2 formulation in the gut because it increases lactobacillus. Okay, so the next one is going to be pecans, and it improves gut redox balance and may favor quinone biosynthesis efficiency. So quinone is like another word or derivative of vitamin K2. So pecans high in elagitannins and antioxidants, and promotes butyrate producing bacteria. Now butyrate is a something for another video. Okay, so the quinones, including the menaquinone, which is for vitamin K2, they function in the electron transport chain. So any nuts and seeds that can help with that are going to be peanuts and macadamia nuts. Macadamia nuts might be a better source or option compared to peanuts, because peanuts, they do have aflatoxins, and many peanuts, especially peanut butters, have hydrogenated vegetable oils. So there's a lot of problems with aflatoxins and hydrogenated vegetable oils. So maybe it's better to go with the macadamia nuts. So the mac nuts support membrane integrity of gut microbes, and lactobacillus happens to be a gut microbe. There are also macadamia nuts. They help the bacterial membranes that are involved in electron transport systems using quinones. Now, vitamin K2 is a quinone, so that works in the electron transport chain, which is a topic for a different video. This section is going to be short for vitamin D and a vitamin K. So basically, vitamin D as calcitriol increases intestinal calcium absorption, promoting synthesis of certain vitamin K dependent proteins. But high vitamin D alone can increase a vitamin K dependent protein production, but it may outstrip available K if intake is low, leading to vitamin K deficiency. So low vitamin K and then taken with vitamin D will just lower that vitamin K2. So it's important to ensure adequate intake of both D and K through diet or supplements. Okay, so quick recap. MK7 is better than MK4 because MK7 tends to last longer with possibly greater extrahepatic effects for the liver. You can enhance K2 in kefir by raising acidity to 5.5 to 6.5. Also, grass-fed kefir with high fat content will also increase vitamin K2 absorption because vitamin K2 is fat soluble. And last but not least is that taking vitamin D with low vitamin K will eliminate the vitamin K that is left. So it's important to take both vitamin D and K at adequate levels to maintain the vitamin K2. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.